You're sitting in a room right now. You look around and you see objects, walls, furniture, maybe a cup on a table. Solid things, real things. You think the universe is made of objects, separated by empty space. But here's the truth. The objects aren't fundamental. The space isn't empty. What's fundamental, what's really running the show, are fields. Invisible fields that fill every cubic centimeter of space, whether or not there's anything there to see them. And those fields aren't just mathematical abstractions. They're as real as the chair you're sitting on. More real, actually, because the chair is just an arrangement of particles, and particles are just disturbances in fields. Let me start with a simple question. How does gravity work? You drop a ball, it falls. The earth pulls it down. But how? The earth is over there, the ball is over here. There's space between them. How does the earth reach across that space and pull on the ball? Newton's answer was essentially, I don't know, and I don't need to know. Gravity just works. It's a force that acts at a distance. Mass attracts mass. The math works, the predictions are correct, so don't worry about the mechanism. But that's not satisfying. It bothered Newton himself. How can one object influence another across empty space without anything physically connecting them? That's where the idea of a field comes in. A field is a property of space itself. The earth doesn't reach out and pull on the ball. The earth creates a gravitational field, a distortion in the fabric of space that exists everywhere around it. When you place the ball in that field, the ball responds to the field at its location. The ball doesn't know the earth exists. It only knows about the field right where it is. Subscribe and like for more videos that explain what's really happening beneath the surface. Because once you understand fields, the entire universe starts to make sense in a completely different way. Now, fields weren't invented by physicists sitting around trying to make gravity less mysterious. They were forced on us by experiments. In the 1800s, Michael Faraday was playing with magnets and electric currents. He discovered that if you move a magnet near a coil of wire, you get a current in the wire. No direct contact. The magnet affects the wire across empty space. Faraday proposed that the space around the magnet isn't actually empty. It's filled with something he called the magnetic field. The field exists independently of the wire. When you change the field by moving the magnet, the change propagates through space and affects the wire. The field is real. It carries energy. It has physical effects. James Clerk Maxwell took this idea and made it precise. He wrote down equations describing how electric and magnetic fields behave, how they interact, how they propagate. And he made a stunning discovery. When you disturb an electric or magnetic field, the disturbance doesn't stay put. It travels as a wave, spreading outward at a specific speed. And that speed turned out to be exactly the speed of light. Maxwell realized light is an electromagnetic wave. Light is just the electromagnetic field oscillating, propagating through space. No medium required. The field itself is the medium. This was revolutionary. Before Maxwell, people thought light needed something to travel through, a substance called the ether filling all of space. But the ether was never found. It doesn't exist. Light doesn't need a medium. Light is the medium. Or rather, light is a ripple in the electromagnetic field, and the field is everywhere, always, whether or not there's light. Now here's where it gets truly deep. In the early 1900s, quantum mechanics arrived and changed everything. Physicists discovered that fields aren't just smooth, continuous things. They're quantized. They come in little packets quanta. For the electromagnetic field, those quanta are photons. A photon is a localized disturbance in the electromagnetic field. When you detect a photon, you're detecting a tiny excitation of the field. But it's not just light. Everything is fields. Electrons aren't little balls orbiting atoms. Electrons are excitations in the electron field. Quarks are excitations in quark fields. Every particle in the universe is a disturbance in some underlying field. The fields are primary. The particles are secondary. The universe isn't made of particles. It's made of fields. Particles are just what we see when we poke the fields hard enough. Let me give you an analogy. Imagine a perfectly still pond. That's the field in its lowest energy state. Now throw a rock in. Ripples spread across the surface. Those ripples are like particles' localized disturbances propagating through the underlying medium. The water was always there, but you only notice it when it's disturbed. Same with fields. They're always there, filling all of space, but you only notice them when they're excited into particles. Here's the kicker. Even when there are no particles, the fields are still there. The vacuum state with no particles isn't empty. It's a seething sea of quantum fields in their lowest energy state, with virtual particles constantly popping in and out of existence due to quantum fluctuations. The vacuum has energy. It has structure. It's not nothing. It's the fundamental fabric of reality, and particles are just wrinkles in that fabric. So when you ask, what fills empty space? The answer is fields. Gravitational fields, electromagnetic fields, electron fields, quark fields, Higgs fields. Dozens of fields, all overlapping, all interacting, all existing everywhere at once. You're not surrounded by empty space. You're immersed in fields. You are fields. Your body is a collection of electron field excitations, quark field excitations, electromagnetic field excitations, all interacting according to the laws of quantum field theory. And here's why this matters. When we say particles are fundamental, we're implicitly assuming the universe is made of discrete, independent objects. But that's wrong. The universe is fundamentally continuous and interconnected through fields. An electron here and an electron there aren't separate things that happen to be similar. They're both disturbances in the same electron field that fills all of space. They're connected at a deeper level. Quantum field theory doesn't just describe particles. It describes the underlying unity of nature. Now, I can already hear the objection. This sounds like philosophy, not physics. But it's not. This isn't speculation. This is the structure of our best theories. The standard model of particle physics is a quantum field theory. Every prediction it makes, and it makes predictions accurate to 10 decimal places, comes from treating particles as field excitations. The Higgs boson, discovered in 2012, is a ripple in the Higgs field. Photons are ripples in the electromagnetic field. Electrons, quarks, neutrinos, all ripples in their respective fields. This isn't metaphor. It's the mathematical structure that describes reality with extraordinary precision. Feynman understood this deeply. He spent much of his career developing quantum electrodynamics, the quantum field theory of light and electrons. He knew that particles aren't fundamental. He knew that fields are the real story. And he knew that most people find this incredibly hard to accept, because our brains are wired to think in terms of objects, not fields. But nature doesn't care what's intuitive. Nature does what it does, and our job is to figure it out. So what is a field? It's a property of space that can have different values at different points. It exists everywhere. It carries energy and momentum. It can be excited into what we perceive as particles. It's the fundamental ingredient of reality. The universe isn't a collection of objects floating in empty space. It's a tapestry of interacting fields, and particles are just the threads where the tapestry is woven more tightly. That's the truth about fields. They're invisible. They're everywhere. And they're running the universe, whether you notice them or not. Once you see it, you can't unsee it. The world stops being made of things and starts being made of fields. And that's far stranger and far more beautiful than any story about solid objects and empty space.